So I'll just give you a small brief of function before getting into exponents and logs. So when we say y is equal to fx is a function, so in that x is called as domain values and y is the range values. Okay, now it is not as simple as their names. Domain are all legitimate x values which will get us some finite y value. Okay, so that's why there is a restriction whenever we write down the value of domain. So if you will apply restriction on domain only, then range will be automatically sorted. So always remember that when we have to find range of any function, we do inverse of that function and then we find the domain only. Because in all, we just know how to find domain. We don't know how to find range. Range is not a separate topic. So that's why you will notice that first we switch x and y, then we make inverse function. And for inverse function, we find domain only. That becomes range for the regular one. Okay. Now these restrictions change from function to function. In that category, we have two of the functions. One is exponents, or we can call it as exponential function, and logarithmic function. Now, exponential and log functions are actually inverse of each other, to be very precise. Okay, they are of same family, they are inverse of each other. So when I write y is equal to a to the power x, this is called as an exponential form where a is called as any base. It is probably a number only. It is very less chances that it will be a variable. If it will be a variable, then it will go towards a polynomial function. I'll just go back to that slide. Okay. So when the base is a variable, then this is not treated as exponential. This is a misconception. We just understand that exponential is something in which we have power. So with that definition, y is equal to x square also becomes exponential, but it is wrong. Okay, in an exponential function, the base should be a constant. Okay, constant can be any number. Normally, when this base is equivalent to e, this takes us to ln x, okay, or ln x. So this is how we get to ln x. We will come to that in the next slide. Okay, so this is a very fundamental thing you should know, that when we say something as exponents, exponents means it should have some base raised to some variable power. Okay, x is a variable. Okay, now before getting into log, we will first understand graph of e to the power x or a to the power x. There is one more very important concept which you have to understand, that whenever we are writing a to the power x, a is a general term which will comprise all the constants, everything. Okay. When I'm writing a to the power x, so a is a certain number, whether fractional or decimal or anything, it doesn't matter, but it is a number. So whenever a number is raised to some variable power, then it can never have a negative value. It can never have a negative value. What does that mean? If you look at the graph, simultaneously you can make the graphs of any like 2 to the power x, 3 to the power x in your calculator also and check. You will get a graph like this. Okay, so this is a graph of an exponential function, which we can just write in general a to the power x. You will notice one thing, that in this graph, it is not going below x-axis. Okay, this is a very important point. Many students do mistake over here. If they will think that if x is negative, then it should be negative. Is it like that? Answer is no. When x is negative, I'll give you an example. Let's say if we have a to the power -2. So it will become 1 over a square. It will become a very small value. So you can see over here then that when the x values, when the inputs are negative, this function is becoming almost equal to 0. Almost equal to 0 means it is having a very small value. So whether the power of x is positive or negative to any extent, the overall a to the power x is always positive. Okay. And this restriction, you can see that it cannot have a negative value, means I can say that range of e to the power x is y belongs to r plus. R plus means all positive real numbers. There is not even 0 covered over here. This x-axis, which is y is equal to 0, is acting as an asymptote. When we talk about domain, so domain is all x belongs to R. Now, as I was saying in the beginning, that exponential function and log are inverse of each other. So all of you should know this thing, that when we say y is equal to x and y is equal to fx and y is equal to f inverse of x, their domain and range are switched always. So if domain of fx is, let's say, x1 and range is y1, I'm just taking a certain value to make you understand better, then domain of f inverse will be y1 and range will be x1. Look, x1 and y1 are not certain values, these are intervals only. But you just try to understand that domain becomes range and vice versa. That is what happens in inverse. So that is what we will see over here. You can see domain and range for a to the power x. When we will go to y is equal to log x to the base a, I will come to that how we come to this type of function, okay? But in this, if you remember, we have discussed this graph of log is like this, okay? And the domain will be only positive real values and range will be all real values. This is exactly opposite of a to the power x. So that is why a to the power x and log are inverse of each other. And that is why in a questions of logarithm, whenever we take anti-log, so anti-log will give me a to the power y is equal to x. Okay, I have taken anti-log exactly of that. I'll take with one example also. So now let us start from the beginning. If I have y is equal to a to the power x, everyone have done this step, that when we take log on both the side, there are properties of log. So because of which I will get log y is equal to log of a to the power x. Now base I can decide as per my choice. Okay, so what I'll do, I'll just take base as a only. So when I take base as a, I will get log y to the base a is equal to x log a to the base a. This is also a property of log, that log of a number to the same base is always 1. Okay, why it is 1? For that, the reason comes from anti-log only. When you will raise this thing to the power of this, you will get a only. Okay, that we will justify. So the point over here is that we have log y is equal to x. And now to find inverse of a function, we always do one step where we switch x and y values. Now these switching of x and y values can be done in the beginning or in the end. That depends from teacher to teacher and that depends from school to school. Okay, we have done both the things in earlier classes, so it is up to you whether you want to switch it before or now. I'll be doing it now. And if I switch x and y, I will get y is equal to log of x to the base a. So I just wanted to show you that y is equal to a to the power x. When we found inverse of that, we reached to this. And these can work in both the direction. If we say y is equal to log x is a function, then anti-log will be that. Okay, now in anti-log, why can't we see a to the power y is equal to x? Because we have switched x and y values. Okay, example. If I have log of 2 to the power 2 to the base 5, log of 2 and base is 5, and that is equal to x. Then from here, when I will solve, I'll get 2 is equal to 5 to the power x. And this is the fundamental definition of log, that power to which base must be raised. Who is the base? 5 is the base. Power to which means this value, whichever is written on the right hand side. So power to which base must be raised to get the number. Get the number means the number for which we are trying to find the log is called as log of a number. So logarithm of a number is power to which base must be raised. Okay. And this step is often used in our questions wherever we have to solve, or like whatever they're asking the question, we can use these type of steps. We'll just do one question from log, okay, after doing the properties. But before I proceed ahead, if there is any general question, you can ask. Okay, so let's move on then. So the next part is properties. The first property is log of m plus log of n is equal to log of mn. Whenever you are remembering the properties or you are writing the properties, it is not required to mention the base. Base can be decided as per the question. Okay, so right now you keep that space in your mind that here I can write anything as per my choice. It can be 1, it can be 2, it can be anything. Okay. Before moving on to further properties, I would like to clear it out that when we say log x to the base a, there are certain conditions. For example, x should be greater than 0. Inside the logarithm, you cannot put any negative value. But y belongs to r. It means log of a number can be positive, negative, anything. Okay, it can be 0 also. Can anyone tell me when the value of log is 0?
So when the base is 1,
Yeah,
no,
when the power is 1.
When x is 1.
next is 1, yeah.
Okay, so at x is equal to 1, y will be 0. So this is also a noteworthy point. It can be observed in the graph also. This point is 1 comma 0. For all the graph, it will be same. Okay. So log of a number, log of 1 to any base is always 0. That we will mention in a result. Log of 1 to any base is always 0. Okay. And how will you justify that? If you try to take anti-log of this, you will get a to the power 0 is equal to 1. And everyone knows that any number to the power 0 is always 1. So it will justify the fact. Moving on to the next property, log of m minus log of n is equal to log of m by n. Next, log of m to the power n will be equal to n log m. Log of m to the base n can be written as log m over log n to any base of our choice. So fundamentally, we have these 4 properties. It can be bifurcated into more, but it's not required. Okay, so these are the things which you should have in your mind. I would suggest not to look on the formula booklet for these properties. Okay, you should practice enough amount of questions so that these properties should be there in your mind. Questions will be analytical. This is a very simple question, but yeah, it will make you understand how we have to solve equations involving log. First thing, you should always like how to begin with the question. If you look at the base on both the sides, if bases are different, then you should first try to make both the bases same. Okay, that should be your very first step. Now, if you want to do a change of base on both the side, it is your choice. Or I would suggest to apply change of base only on right hand side and make bases as 4 everywhere. Okay, so on right hand side, I will write it down as log of 13 minus 4x to the base 4 over log of 16 to the base 4. Okay, this base is decided by us only. So it means you should practice enough to come to that situation that you should be able to decide what is the base. Now, why we have taken 4 as the base? Because it was evident that we have 16 over here, that is power of 4. So this 16 can be written as 4 square, and in the denominator, I'll be left with 2 only. So the next step is log of 13 minus 4x to the base 4 divided by log of 4 square to the base 4. On the other side, I will keep it as it is. Next step will be in the denominator of right hand side, that 2 will come in front, and then log of 4 to the base 4 will be 1. So effectively, I have only 2. That 2 will come on the left hand side, and finally, I'm writing this step. So 2 log 2 minus x is equal to log 13 minus 4x. Both the sides bases are 4. If that creates confusion, put brackets wherever required. Okay. Now the
question.
yes, medicine.
So log.
This 2 will go on the other side, and it is multiplied with this.
Okay, sir.
You are clear, na, that on the right hand side denominator will get 2.
B2, yeah.
That 2 will go on the other side.
Yes, sir.
Okay, in the steps, anyone have any question till now? Okay, moving on. Then we will send this 2 in the power of this 2 minus x. Okay, we have this property log of m to the power n is n log m. We can also do the reverse. So the reason for doing that is I wanted to make log of a is equal to log of b to same base. Okay, so I'll write it down in the property only. It is not a property, it's like a result. When we have log of a is equal to log of b and bases are same, let's say both have base a only. This implies that a is equal to b. This is a very common step we use in solving equations for log. So my objective is accomplished. I wanted to make both the bases same. It is done. I will just equate the remaining part. 2 minus x whole square is equal to 13 minus 4x. And now it becomes a regular equation. When you will expand 2 minus x whole square, it will be 4 plus x square minus 4x is equal to 13 minus 4x. Minus 4x will be cancelled from both the sides. And we will get x square is equal to 13 minus 4, that is 9. So that will give me x is equal to plus minus 3. Okay, now whether both the values are acceptable or not, you cannot blindly go with that, oh, it is negative, so we can't accept that. Okay, so for that, the procedure is you look at both the inputs of log. 2 minus x should be greater than 0. Two minus x should be greater than 0. It implies that the value of x is less than 2. Okay, and the other one is 13 minus 4x is greater than 0. That will give me 4x is less than 13 by 4. Okay, when I'm saying x is less than 2, x is less than 2 means, can we take negative 3 also? Answer is yes.
I don't understand
Okay.
what we're trying to do over here. After we get the value of x as plus or minus 3, right? What is this about?
Now we have to decide whether we can take both the values or we can't. Okay, many a times it will happen in questions of log that you will get 2 answers, but you cannot accept both. So you have to reject one of the answer with reason that why you are rejecting it. Okay, so what is the main criteria for that? We have to make sure that whatever we input in the log, it should be positive. Okay, so then we tried to found this thing that 2 minus x should be greater than 0. So that gave me that x is less than 2. Okay, if x is less than 2, it means this will work. For less than 2, this will also work. Okay, then the next one is 13 minus 4x is greater than 0. So that will give me 4x is less than 13 and x is less than 13 by 4. Now 13 by 4 is giving me x is less than 3 point something. Okay, I think 3.25. So x is less than 2 and x is less than 3.25. We have to select the common region out of both of them. Because of that, x is equal to plus 3 is rejected. Minus 3 will be accepted. Okay, if there is any doubt understanding this, please think upon it and you can ask again. Okay, this is bit weird to see. Generally, we reject the negative value and we accept the positive value. But that is a very wrong method to accept and reject. We should check like this, and then based upon the common region, we can accept or reject the values. Now, when I'm saying common region, what I mean to say is one of the inequality is x less than 2, another one is x less than 3.25. When I will plot both of them roughly on the number line, x less than 2 will be this region and less than 3.25 will be this region. So my safe region is having both of them true. I cannot work in this region because when you are putting any value between 2 and 3.25, one of the log will have a negative input. You can check it out. If you put positive 3 over here, so 2 minus 3 is minus 1, which is not allowed. Okay, it means that x is equal to plus 3 is rejected. What I'm saying now, you have to mention that in the reasoning that why you are rejecting plus 3. Everyone is clear with that? So all living plants contain an isotope of carbon called carbon-14. When plant dies, the isotope decays so that the amount of carbon-14 present in the remains of the plant decreases. Okay, this thing is used in autopsy. You might have heard in the news or in the TV, in the movies, that this person has died 5 days before only. How come we are coming to know now? Okay, such type of things. So on what basis you can decide that this person has died 5 days before? On the basis of this calculation. Okay, this is a simple part of chemistry which comes under chemical energetics. Okay, you don't have to get into all those things. You can use these formulas and use maths only. The time since the death of the plant can be determined by measuring the amount of carbon-14 present in the remains. So they are talking about that only. The amount A of carbon-14 present in a plant T years after its death can be modeled. So first thing you should understand this formula carefully. A is the amount of carbon-14 which is present in the plant after T years. Plant has been dead from 10 years. So after 10 years, how much carbon-14 will be there? This is A. A naught is the initial amount. Okay. K will be a constant, which is normally called as decay constant. There are different names. And T is the time in years. At the time of death, a plant is defined to have 100 units of carbon-14. At the time of death means A naught is 100. Now they are saying show that A naught is 100. So this is a very stupid question. It is a question of just common sense. You should know that what is A naught. Now, interestingly, they are trying to challenge your common sense in the question. You can see they have not given anything about A naught and K. It's just that they have given A naught is a constant. So how will you determine that A naught is actually the initial one? Okay, we can do it mathematically also. Can anyone think on that?
So I got t equal to 0.
Very good. So you just put t is equal to 0. If you put t is equal to 0, this equation will give you a is equal to a naught. It means that a naught is the initial number of carbon-14 when the plant died or at the time of death. Time of death will be considered as 0. Next question. The time taken for half the original amount of carbon-14 to decay is known to be 5730 years. Show that K is equal to ln 2 over 5730. Now this question I'll take on the next slide. Okay, so so that I can write something. Relation was A is equal to A naught e to the power minus kt. Half of the original amount means the value of A is A naught by 2. This is decaying. Decaying means the final value of A will be half of the original amount, and in how many years it will be. I think they are asking, no, they have given the years also. They are just asking the value of K. So this is to be done like this. Okay. Then I can take log on both the sides. Okay. Now it is up to you how you are dealing with the question. Okay. Please see to it that mathematically you should be very fine, very sound. Okay. If you're taking log in this situation, it is good. Okay. If you want to make both the exponents positive, you can just crisscross them. You can take the reciprocal and then write e to the power kt is equal to 2. This is also fine. So choice is yours. Okay. Whichever way you like, you can take log. Now in the question, they are saying show that k is equal to ln 2 upon this. Means we will take log to the base e. So taking ln on both the sides, I'll be using this. Ln e to the power kt is equal to ln 2. kt will come in front, applying the property of log. So kt ln e is equal to ln 2. You can see that till now I'm not putting the values because this is a mistake generally any student do. They put the value here only. So then you have to move that 5730 every time. It looks very big. Because of that, it becomes complicated. ln e is 1. The value of k is ln 2 over t. This is a general value. Now in the next step, you will write since t is equal to 5730 years, so k will be equal to ln 2 over 5730, hence proof. Like that you can end it. So in the end, you can put the value of t, that is absolutely fine. Now look at all the steps, and if there is any question, you can ask.
So could you just go through the steps again once, like from the beginning, just to clarify?
Look, this is the formula. A is equal to a naught e to the power minus kt, that was given in the question. Then they are saying that time taken for half the original number of carbon. Half the original number of carbon means how much will be left?
Like,
Half will be left. Okay. If you have you have 1 cup of tea, if you will drink half of it, how much will be left? Half. Okay. So this A is the amount of carbon left. So if half is decayed, the amount of carbon left will be A naught by 2. Half of the original amount. Original amount was A naught. Okay. So that's why I have written A naught by 2. Then I cancelled A naught from both the sides. And I have 1 by 2 is equal to 1 over e to the power kt. E to the power minus kt can also be written as 1 over e to the power kt. Okay, this is a very fundamental step. So that's why I'm saying that instead of using this, you should use the bottom one. Deal with positive exponents. It will be easy to think. Okay, but answer with both will be fine, will be same. So then next step is taking log on both the side. Now this is strictly as per what they want. Like ln is given in the question, so that's why we took ln on both the sides. Ln means log to the base e. Now log is to the base e, so that's why ln e will become 1. Kt will come in front, so kt is equal to ln 2, and then k is equal to ln 2 by t. In the end, we are putting the value of t. Okay?
Yeah.
Just believe me, if you just put the value of t from the beginning. So it is not that this is just a number, but when you will keep on writing 5730, now this thing will become huge. Okay. And then you will have a feel that, oh, this is becoming very complicated. So these are the small things which you have to keep in mind, that when you have to use the given data. 5730 was not required till this step. So I didn't kept the value. Later on,
Yeah.
I just wrote since t is equal to this, hence k is equal to this. I'm done. Okay, so this is how our steps are simplified. Second part is kind of related to this only, in that we don't have to do anything extra. Find correct to nearest 10 years the time taken after the plant death for 25% of the carbon to decay. Now to interpret this thing properly, that will be challenging. Okay, over there only many students will do a mistake. Time taken after plant death for 25% of the carbon to decay. So if 25% is decayed, how much is the left? 75% will be left. Can I say that?
Yes, sir.
Yeah,
I will write 75%. Now 75% can also be written as 75 over 100 or 3 over 4. Okay, so I will write the leftover. Okay, let me write the formula. A is equal to A naught e to the power minus kt. Okay, we already have the value of k now. Okay, we can use this value of k. And A is equal to 3 by 4 A naught is equal to A naught e to the power minus kt. Then what do I have? A naught cancelled. Okay, and then after that I'll do the reciprocal. Okay, why it is recommended to do the reciprocal? Look at this step. If you do the reciprocal, you will get e to the power kt is equal to 4 by 3. Okay, I want you to deal with positive exponents. It will be easy for your mind to understand. Taking log on both the sides will give me ln e to the power kt is equal to ln 4 by 3. All calculations will be done by calculator, so need not worry about 4 by 3. Kt is equal to ln 4 by 3. Till now, I haven't put the value of k. Now I'll be putting the value of k, which is ln 2 by 5730. T is equal to 1 by k times ln 4 by 3. Use exact values which you are getting in your calculator to get the most accurate answer. Okay. Correct to 10 years. I'm waiting for the time. Okay. I'll not do the calculation from here. I want you guys to carry on with the calculation and tell me what you are getting. Basically, when you will put the value of k, it is ln 2 over 5730. So it is 1 over k. So 5730 over ln 2. So ln 4 by 3 divided by ln 2 times 5730 should give you the answer. Is there anyone who is getting the answer?
Sir,
Yes, sir.
2378.
Yeah, that's right. Now
Yeah,
they're
correct.
saying nearest 10. So what should be the rounded off answer?
2380.
It will be 2380 years. Okay. So you can see the question that how effortlessly we have solved everything. Okay. This was one of the most difficult question from the student's point of view. But you can see that at every step in calculation, we are trying to avoid the substitution at the early age. Early stage. Okay. If you will substitute the value of k in the beginning, then once again, you imagine what will happen to this calculation. At this level only, if you put k is equal to ln 2 over 5730, you will be scared that what can I do now? Okay. So do it in the end and then you'll get the answer very easily. Definitely more questions are needed on this to gain confidence. But yeah, this is what we have in log and exponents. There's nothing else conceptually. Try to practice questions directly on it. Okay. Everyone have access to Exammate. So first try to finish off minimum 3-4 years paper from there. Okay. Jasmine, do you use Exammate?
Yes.
Okay. Fine. Let's move on to our next topic. We have to rush now to finish it off fast. Our next topic is binomial theorem. In binomial theorem, the concept of Pascal's triangle is obsolete. Okay. Why am I saying that? Because it will be helpful only when you have power 3, 4, 5 like that. So I would suggest keep Pascal's triangle as an alternative and try not to use that. Rather, you should understand that NCR notation. We will be focusing more on that. Okay. I will still tell you Pascal's triangle also, but that is, you can keep it aside. Okay. That is very limited to powers 3, 4, 5 only. So if I have a plus b to the power n, then the expansion of this binomial will start from nc0, a to the power n, b to the power 0. nc1, a to the power n minus 1, b to the power 1, and it will go on till ncn, a to the power n minus n, b to the power n. Now, in this expansion, there are few noteworthy points, like the first one is number of terms. Number of terms will always be the highest power plus 1. Evidence for that is when you expand a plus b whole square, you will get a square plus 2ab plus b square. Everyone knows this identity, and this is an easiest example to make you understand that if power is 2, the number of terms are 3. Same thing is replicated over here. If power is n, the number of terms will be n plus 1. And if you want to check over here, then you can see this NCR notation. It starts with NC0, and the real counting starts from here, NC1 till NCN. So NC1 till NCN will be n terms plus that NC0. So that is how n plus 1 terms will be there. Another noteworthy point over here is that powers of A will decrease from n to 0, while powers of B will
This
increase.
is for the general term, right?
Yeah,
Like the
this is for
general.
the general term. For general, A and B will be this only. Okay. If you change
Yeah.
A and B, then this will change.
Yeah.
So these 2 points are written strictly as per the expansion what I have used. Okay. Will increase from 0 to n. Okay. Now this NC0, NC1, NC2, and so on, these are called as binomial coefficients, for which the earlier attempts were made by Pascal, which we call it as Pascal triangle. Okay. So I'll just write down the terms for Pascal triangle also. In Pascal triangle, there are a few things which we have to consider. Okay. So you should know that in Pascal's triangle, it starts with a plus b to the power 0. So a plus b to the power 0 is literally 1. That's why the first term of the Pascal's triangle is 1. Then the next one is a plus b to the power 2. So it is 1, 2, 1. Okay. Then a plus b to the power 3. It will be 1, 3, 3, 1. Initial and end numbers are always 1. That I can show you here also. NC0 and NCN is always 1, whatever is the n value. If you do 4C0, it will be 1 only. If you do 4C4, 1 only. Okay. Then a plus b to the power 4 will be 1, 4, 6, 4, 1, and so on. This is how we can keep on writing the terms. So it is up to you. If you are comfortable with Pascal's triangle, you can use it, but there will be times where you will realize that this will not help you. So you should understand this expansion properly. Now the next and one of the most important, not one of the most important topic of binomial theorem is general term. Because there is 100% chance for question to be asked from here. Okay, so you should know for a binomial theorem, how do we write a general term? So if I have a plus b to the power n, then the general term will be called as tr plus 1. That will be ncr, a to the power n minus r, and b to the power r. That I can show you in a example. So if I have 2x plus 3 to the power 10, then my general term will be tr plus 1 10cr 2x. 2x means a to the power 10 minus r and 3 to the power r. We will do a question on binomial based on this general term. Consider the binomial expansion. Show that b is equal to 21. Now what is b? B is the third term of this binomial. Okay. And b is basically coefficient of the third term. So how can we show that b is equal to 21? So for that, you have multiple options. You can start with this, that first will be 7c0, then 7c1, 7c2. So basically when you will solve 7c2, you'll get 21. Before moving forward, I'll tell you the expansion for NCR. You should know it manually also. N factorial by R factorial, N minus R factorial. So if I want to solve 7c2, it will be 7 factorial by 2 factorial, 7 minus 2, 5 factorial. In a factorial notation, how to understand it? Whatever number is written over here, that will pop out. If it pops out, one lesser than that will be left inside. So it can be written as 7 times 6 factorial. So like that, the numbers can keep on coming out till we want, okay, till the time we want it to be. So it can keep on coming out till 1, okay, but we can stop it at any place. Why I stopped over here? Because I already have 5 factorial in the denominator. 2 factorial will be 2 times 1 and 5 factorial will be cancelled as it is. 2 1s are 2 3s are 7 3s are 21. This is of 2 marks. Not suggested to directly get the value in calculator and write. Okay, that is not the show that thing. So when they're saying show that, it means you should be able to write these steps. Look at the steps. If there is anything you want to ask from here, you can ask. Moving on to the next part. Third term in the expansion is mean of second term and fourth term. Third term in the expansion is bx to the power 5. I'll take the whole thing. Bx to the power 5. In fact, I have the value of b now. So 21x to the power 5 is mean of second term. Second term is ax to the power 6 plus 35x to the power 4 over 2. Okay, we need to find a also. So for finding a, it will be 7c1. nc1 is always n. nc0 is always 1. Okay, you can remember these things as direct results. So if I have 7c1, it will be 7 only. So I have to in all solve this equation. Okay, I'll take this equation on the next slide and let us see how to solve. So 2 will go on the other side. It will be 42x to the power 5 is equal to 7x to the power 6 plus 35x to the power 4. I can take terms on one side and I can divide everything by 7. So that will give me x to the power 6 plus 5, not 5. We can take this in the middle. Okay, let me do it in the next step. Dividing both the sides by 7. It will be 6x to the power 5 is equal to x to the power 6 plus 5x to the power 4. Now someone from you may think that we can also divide it from x to the power 4. Always remember that if you're dividing in an equation by any of the variable, it means you are cutting off one of the possible answer. Okay, I'll tell you how. So right now, don't divide, just take the terms on one side. So x to the power 6 minus 6x to the power 5 plus 5x to the power 4 is equal to 0. All terms are taken on one side. I'll take x to the power 4 common, so I'll have x squared minus 6x plus 5 is equal to 0. When I will factorize this, I will get x minus 5, x minus 1. Now from here, you can see that there are three factors. X to the power 4 is also one of the factor. So that will give me the value of x as 0. X is equal to 5 and x is equal to 1. Whether it will be accepted or not, that is a secondary part. But primarily, these three are the answers. Okay, so you can see that we should never divide when we are dealing with such steps, okay, such equations. In the end, you should take it as common and then you can write it down as one of the answers. But now we have to check whether we can accept x is equal to 0 or not. So it is given in the question where x is not equal to 0. It means we will reject this value and we will mention the same reason. As x is not equal to 0, the possible values of x will be 5 and 1. That's it.